That's the only thing we have left in this chapter, is to solve the rational equations. After that, we're just going to get ready for the test. Okay, and that'll be tomorrow, and that'll be Thursday as well. So we're going to solve these rational equations. Before we get into that, I want to relate it to something else you've already seen. Okay, if we are doing, you know what, I'll just make this a little bit simple. We'll make this 10 over 3, I guess. If we are doing this problem, and we're actually trying to put it in standard form, if this is a linear equation, we're trying to put it in standard form. The thing that makes this a problem is that there's fractions in it, right? You can't have fractions in the standard form of a linear equation, if you remember that. How do we get rid of those two fractions? What do we do to get rid of the fractions? Multiply by the least common multiple of the denominators, or the least common denominator, if that makes sense. The least common denominator in this is 15. So we're actually going to multiply all three of these fractions by 15. Or I'm going to do this for emphasis, 5 times 3, just to kind of make it a closer relation to what we're doing today in class. So essentially what we do is we multiply this times 5 by 5 times 3, and this by 5 times 3. We distribute it, so we're left with 5 times 3 over 1 times x over 5 plus 5 times 3 over 1 times y over 3 equals 5 times 3 over 1 times 10 over 3. Now that's a lot of extra steps that you probably wouldn't show, but I'm doing that to emphasize what we're doing today in class. Notice those two factors are going to cancel out, and we're left with 3x. Next, those two factors are going to cancel out. We're going to reduce and make 1. So then we're left with 5y. And on the right-hand side, those two factors are going to cancel out, and we're going to multiply it. But I'm not going to do that yet. You get 5 times 10. Does that make sense? Now, when you actually multiply 5 by 10, it's actually in standard form. That got rid of all the fractions. Today in class, you're going to take a look at questions that are ugly-looking fractions, or solving an equation with ugly-looking fractions. You're going to multiply both sides of that equation by the least common denominator of all of the fractions, and it's going to get rid of all of the fractions at once. Okay? That's essentially what we're doing today. If you remember that skill, you'll be successful. Okay? If you understand this, you'll be successful. Okay? And that's what we'll see when we come back. Okay, we are solving rational equations. In order to do that, the thing that makes them crazy and difficult to do is because there's multiple fractions. If there weren't fractions in it, it turns into a problem that we've already solved from Chapter 5 and Chapter 6. Okay? So if we get rid of the fractions, we're in really good shape. To do that, we multiply through by the common denominator, the least common denominator of all three of the fractions. And it gets rid of all three of the fractions at the same time. What did you guys find to be the least common denominator? Somebody say it. Was 2x minus 3, x plus 3. Now, in order to find that officially, you have to know what this is factored. Right? So you actually have to factor that first. So I'm going to write that step down. This becomes, we carry over everything down here. And we factor the denominator. We actually don't need to factor the numerators at all because we're gonna want them multiplied out anyways. So that's our setup. Once we factor that denominator, now we want to multiply both sides of the equations by the least common denominator. And that is going to get rid of all of our fractions. Both sides of the equations by that. Essentially what we wind up doing is we wind up distributing this to all three parts. Long ways, when we write out all of the steps, of which you can do if you're struggling with this and not understanding it. Multiplying the first fraction times the common denominator. Multiplying the second fraction times the common denominator. I'm writing it over 1 so that you can see that it is in fact itself a fraction. And I know this is a lot of writing, guys, but it's there to help you out. Now what you'll notice is we have a bunch of fractions times themselves, or times the common denominator. Some factors are going to cancel or reduce. Divide out and make 1. This x plus 3 and that x plus 3 will reduce to make 1. Plus that factor and that factor cancel to make 1. Reduce to make 1. And then on the right side of the fraction, that factor and that factor reduce. That and that reduce. So we're left with 3x squared plus 6. We're allowed to cancel those factors because they are, in fact, factors of the numerator after it's multiplied and factors of the denominator. We are not canceling factors of terms of a numerator or terms of a denominator. It's different. Now this turns into a problem that you've already done before-ish. You multiply it out, simplify it, it's currently a quadratic, and we solve it by setting it equal to 0 if it stays as a quadratic. If it's no longer a quadratic, we just get rid of it. Or we just get rid of the x squared so we can do it like a linear equation, and it's barbecue pork from there. Okay? So right now, go ahead and multiply this out, and look back up here in a few seconds. So after you multiply out the first sets of binomials, you should get 2x squared plus x minus 6. Second set of binomials, you should get x squared plus 2x minus 3 equals 3x squared plus 6. Then combine like terms. We're just simplifying here. You get 3x squared plus 3x minus 9 equals 3x squared plus 6. You're going to notice that there's a 3x squared on either side of the equal sign. So when you turn around and you subtract 3x squared, those are going to drop out. Those are going to equal 0, so we no longer have them. Then it's barbecue pork from here. It's just a linear equation that you already know how to solve. Add 6, divide by 3. Or add 9, rather. And then divide by 3. And you get x is 5. One thing you want to be careful of is this value could be extraneous based on what the denominators of the function or the equation was to begin with. So you have to take a look at the original denominators and what makes that equation undefined, what values of x make that equation undefined. In order to do that, you actually have to remember what that third denominator factors as. Okay, so the things that make those denominators or those fractions undefined would be 3/2 and -3. Neither of those are 5. So our answer is okay, it's not extraneous. It would be extraneous if it can't go into the original problem. Okay? We'd get an undefined value and it just wouldn't work. Go ahead and give the second one a try. The next one. What do you guys find as the LCD, the least common denominator? X times x plus 2. Or the reverse. Yep. That third fraction, the 2, is really 2 over 1. You're going to multiply both sides of the equation by x times x plus 2. X times x plus 2. So one, I'm going to show you the long way. And then some common factors are going to reduce, and we're going to get rid of all the fractions, which was our goal when we were going to simplify this. That becomes x squared because x times x is x squared. These two guys are common factors, and they reduce. And then in the next one, there are no common factors, so they do not reduce. And then we distribute and we simplify and solve. Just keep cranking it up. So it's 2x squared plus 5x plus 2 equals x squared plus 2x squared plus 4x. And we get all the terms on one side of the equation. We still have like terms to combine there though. And I'm going to subtract them all and put them on the right hand side. Zero equals x squared minus x minus 2. And that is factorable as x minus 2, x plus 1. And that gives us two solutions. You get x is 2 and x is negative 1. Okay. From that, you've got to take a look at your original equation and make sure those two values are not undefined. Okay? That's how you check it. Neither of those are undefined, so those are both your solution. Okay. Could you have no solution on these problems? Absolutely, if the answers you get make the problem undefined.